Welcome back to Josh Does Math. In this video, we're going to be finding the derivative of a function using the limit definition of a derivative rather than the power rule for derivatives. So the limit definition of a derivative looks like this. F prime of x is equal to the limit as h goes to 0 on f of x plus h minus f of x all over h. So we're going to be using that with this third degree polynomial up here, which means it's going to get pretty big whenever we go to distribute stuff. So see if we have enough room going across the page here. So f prime of x is equal to the limit as h goes to 0 on, I'm going to start plugging stuff in here. For f of x plus h, I'm going to use the f of x that I'm given up here, this polynomial, except for every x, I simply put in x plus h. So that's going to become 2x plus h to the third power minus 2x plus minus 3x plus h squared plus 6x plus h minus 5. Then I'm going to be subtracting f of x. So that's just the f of x that I'm given. So that's minus 2x to the third minus 3x squared plus 6x minus 5. And this is all over h. It's already big and I haven't even distributed anything. So now, for this next step, I'm going to distribute and use FOIL and whatever else I can to split this up a little. So I'm going to write 2, and I'll do FOIL with my first two factors of x plus h here. So that's going to be x squared plus 2xh plus h squared times x plus h. And for the second two factors of x plus h here, I'm also going to FOIL those. So that's x squared plus 2xh plus h squared. And I'll distribute the 6 plus 6x plus 6h minus 5. And I'm going to distribute this negative sign through the last polynomial here. So that's going to become minus 2x to the third plus 3x squared minus 6x plus 5. That's all over h. So I still have another set of distributing right here, and another I need to distribute this to each of these terms in here. So instead of writing this entire thing out again, I'm going to cancel some stuff during this step, so I don't need to write out so much for the next step. There will also be less of a chance of errors if I cancel some stuff now, instead of copying all of this. So I'm going to cancel this 6x right here with the negative 6x. And I'll cancel the negative 5 with the positive 5 here. And that looks like everything that easily cancels. So now I'm going to write out my next step. Limit as h goes to 0 on 2. So now this is going to become x squared x plus h plus 2xh x plus h plus h squared x plus h. I'll distribute the 3 right here. Actually, I'll distribute the negative 3. So that's minus 3x squared minus 6xh minus 3h squared. And I'll just tack on whatever was left from the previous step. We'll see if maybe distributing that 3 allows us to cancel some more stuff before we deal with this at the beginning here. So we have a positive 3x and a negative 3x. Those can cancel. And that looks like everything that cancels. So now we need to deal with the thing we've been avoiding the whole time at the beginning here. So I'm also going to distribute the 2 through all of these terms, see if we can do all of that in one step. So this becomes x to the third times 2. This becomes 2x squared plus h, or 2x squared h. For this next term here, this is going to become 2x squared h times 2. So 4x squared h. This is going to become a 4x h squared. And finally, we'll have 2h squared x, and then I'm going to have 2x h to the third minus 6xh minus 3h squared plus 6h minus 2x to the third all over h. So we'll get the next step ready here, but we'll cancel a lot of stuff right here, hopefully. So already I can see 2x to the third cancels with negative 2x to the third. And I see nothing else that easily cancels. A lot of stuff will combine, so I guess we'll write that in this step. So I see 2x to the third h plus 4x, or 2x squared h plus 4x squared h. And that's all of those terms, so that becomes 6x squared h. Right here I have 4x h squared. And that's the only term of its kind. 4x h squared. Here I have 2h squared x. That's the only term of its kind. I have 2h to the third. And these things don't look like they cancel with anything else. So we had very little cancellation right there. But it's enough to get us out of that 0 over 0 indeterminate form, because that's what we had at the very beginning here. If I were to just solve this as a plain old limit without knowing anything about what kind of limit it was, I would immediately try to put in 0 for h and see if I can just do it with direct substitution. And if I did, I would have gotten 0 over 0, which doesn't tell you anything about the limit. So our goal this whole time is to get out of that form. So I've just been manipulating the numerator this whole time up until this step here. And at this step, you can see how we can cancel an h out of the numerator and denominator, since every term in the numerator has an h. So for this next step, that's what I'll do. So we don't need the fraction bar anymore. This is going to become 6x squared plus 4xh plus 2hx plus 2h squared minus 6x minus 3h plus 6. And actually, here's something that I missed before. Since I wrote these variables in a different order, I didn't realize that they have the same combination of variables, so we could have added these earlier. But it doesn't hurt anything just to add them now as opposed to earlier. So I'll combine these two right here just in this step. So I'll make this a 6xh squared. Or it's not squared anymore because we divided by h. So just combine these here. Not that we needed to, but it doesn't hurt to. And now I'm going to evaluate this limit using direct substitution. And we'll see if we still get 0 over 0, which we shouldn't because we don't have a denominator anymore. So if I put in 0 for every h, we don't need the limit notation anymore. If I put in 0 for every h, I get 6x squared. This term drops out. That term will drop out. That term will drop out. So I'll just be left with those terms. That's all I'm left with. So this means that the derivative of f with respect to x is equal to 6x squared minus 6x plus 6. And that is the final answer. So thanks for watching.